Hi, I'm Vilnius Vesma, a specialist in energy management and somebody who enjoys training people in that subject who don't know very much about it. Today's kitchen tabletop talk is about three-phase electricity supply. It's something we need to know about because all substantial buildings have their electricity supplied in that manner. But let me start from basics. And there's going to be a bit of noise in a moment because I'm starting a pump to demonstrate most people's perception of electricity, which is that it is like something that just flows into the building through a pipe. But electricity flowing in one direction through a circuit, direct current, is not normally what we deal with. Let me just stop the pump, remove the clutter, and I'll show you what we do when we want serious amounts of energy, of electricity. So the electricity feeding a building is normally fed in as alternating current. So if we think about water flowing through a pipe as the analogy, the equivalent would be the water flowing backwards and forwards in the pipe. So the electricity flowing into your building in alternating current flows in and out continuously, reversing direction 50 times a second. But for large buildings, because of the need to deliver more power and also to match the way that the public electricity supply works, the electricity comes into most substantial buildings through three wires. Now, the important thing to understand is that all three of these cables are live, so you could get a fatal shock from any one of them. They're all live, in a sense they're all the same, and we designate them as red, yellow and blue. Now, let's go to the power station and start up our three-phase electricity supply. If you watch the plungers, you will see that they're going up and down, just like the single plunger went in and out before, so that's the alternating current. But the alternation in current is a third of a cycle apart. They're said to be out of phase. Now, if we imagine that the height of the plunger represents the voltage at any instant, then I can put a scale next to the plunger and you can see the alternation in voltage. We start the power station up again. Look at that front plunger next to the scale, down to its minimum. Let me just mark where the minimum is. And then up to its maximum, which is there. So the distance between those marks, if you like, is the alternating voltage that we get from a single phase supply. Now the interesting thing is that if we look at the voltage between any pair of plungers, or pair of phases, we're going to get a different answer. Now we're looking at the difference in height between this plunger and the one behind it. So one goes up, the other one goes down. So about that point there is the maximum voltage difference in one direction. And at that point there is a maximum in the other direction. And you can see that the alternating voltage measured between any two cables is almost twice the magnitude of the alternating voltage in a single cable. And if you've ever wondered why it is that the electricity supplies to the equipment in your building is at 230 and 415 volts, that's the reason. The 415 volt equipment is three-phase equipment fed with three cables at the full voltage, and the 230 volt equipment like sockets and light fittings is fed from a single phase. That's it, three-phase electricity supply. Thanks very much for listening.